In order to do a polarization or anisotropy experiment, it is necessary to calculate the g-factor first. In order to calculate g-factor, go to the Setup menu and select the time-based experiment that you'll be running. Enter in your excitation and emission wavelengths, the points per second, and the duration of your experiment. After you've completed these parameters, go over to the Polarizers tab and check Use Polarizers. You will now be collecting g-factor, so click on the radio button g-factor. Make sure that the polarizer on the right-hand side of the instrument is set to the horizontal position. That's shown by these horizontal lines in the polarizer. The left-hand side of the instrument, or emission 2, should be set to the vertical position. Once you've selected the g-factor and the polarizers are set accordingly, click the Accept button and then start the experiment. Notice you'll be generating two traces, a horizontal-horizontal and a horizontal-vertical trace. You only need to collect this data for a few seconds and then click Stop. Now go back to the Setup, back to the Polarizers tab, and select Polarization Anisotropy. Down here you should see the last acquired global value, and this should show you what the g-factor value was for your instrument. You are now ready to start the polarization and anisotropy experiment. Before you start it though, it's a good idea to generate a derived trace so that you can display it on the screen. Click on the Traces tab and then add a new derived trace. Select vertical-vertical as source 1. Under the function, choose polarization, and under source 2, choose the vertical-horizontal. It's a good idea to place this in graph 2. So uncheck graph 1 and enable graph 2. This way the derived trace, which we'll rename and call polar, will be shown in graph 2. You can now click Accept and start the experiment. When you start the experiment, you'll see two graphs will be drawn. Graph 1 is the raw data. Graph 2 will show the polarization and anisotropy values. You can either wait until the experiment times out after 60 seconds, or you can click Stop. Now you can see what the polarization and anisotropy values are. Here you can see it shown in window 2. If you want to see the graph values, you can toggle the graph and you will see the values. That's all there is to running a polarization experiment using Felix 32. Thank you.